So same problem statement, but different approach, using only one timer. Okay. So now we'll open the Indra logic. So there all other settings are same. Go to File, New, and L2003 version. Okay. Then okay. Okay. Now so here same as usual, like we'll take one start button, and so what is the address we want? We want to have say for example inline. So inline means we should have inline modules. So go to resources, PLC configuration. So usual procedure, adding the inline modules, DI16 first, DO16, AI2, AO2. Okay. Now go back to the PLC underscore PRG, and there is one more library is missing actually. So go to library manager, right click, additional library, standard library you have to search. Okay. Go back. This is a programming window. Now we have taken a variable called start. Address is percentage ix 1.0, and to store the start signal, we'll take one bit memory, that is name is hold. I'm not typing any address for the hold variable. It is assumed that system variable. So to store the start signal, so we should have a latching. So this is nothing but hold variable placing parallel to the start button, so that it is continuously on. It's only off by operating stop. Stop is another input. So percentage ix 1.1 is the address. Okay. So this is done. Next is, if you want to simulate, then go to simulation mode, then online login. So the purpose of this network or programming line is to store the start signal continuously. Even if your start button released, still the hold variable is high. So that is a electrical latching or the latching logic, control F7. So when you press stop, it is going to erase. Okay, so this is already discussed. Now we know that when start button is operated, hold variable is high, so that is a reference. So we'll take one hold variable here, and then go to the function block. There is a timer here. I will take on delay timer, and I name it as T1. When you're declaring function block, don't type any address and click on OK. Next, what's the time? T hash 15 seconds. Total duration is 15 seconds, right? Then to read the value, I'll take one D1 variable, and the type should be time. Okay. Now I'll take a new network. There, right click, box with EN option is there. Box with EN means enable actually. So box with EN option you take it. There by default AND gate is there. Now I will take GE. GE means greater than equal to. So T hash 5 seconds. After 5 seconds we want some action. What is that? M1 is off, M2 is on. So this is T1.et. Okay, before that what is required? Whenever start button is operated, immediately without any delay, what is our requirement? M1 should be on, right? So I will use hold variable to switch on the motor 1. Motor 1. Then address is percentage QX 1.0, right? Immediately, say for example, okay, here this is one more memory bit called M1. I am not typing any address. I'll go to simulation. So now when start button is operated, immediately motor is on without any further delay, right? So after 5 seconds, what is our requirement? We should switch off M1. So I am using greater than comparator. I am comparing with 5 seconds. Why greater than equal? If you take only greater than, if you take only GT, there will be a difference. It will not switch on, it will not switch off exactly 5 seconds. After 5 seconds, maybe 5.5 or 6 seconds, we don't know. So there is an error. Okay. Greater than equal means even if it is equal to 5 seconds, it will switch on something. Okay. So it is better to take greater than equal to, not GT. Next, we know that after 5 seconds, M1 will be on. So M1 means is a system memory bit. So that what is our requirement? When M1 is on, motor 1 should be off. So off means I will use normally close contact M1. And what is another requirement after 5 seconds? What is the other requirement? Same thing, M1, but motor 2 should be on. Motor 2 address percentage QX 1.1, right? Next, again right click on the same network, box with EN. You can add parallel GE blocks. So again one more GE, but here time is T hash 10 seconds. And here what is the comparison? I am comparing T1 time, that is ET. And here I will take one more system memory bit, that is M2. Enter. Don't type any address. Click on OK. So what is our requirement when M2 is on? It means after 10 seconds, equal to or greater than 10 seconds. So M2, when M2 is on, it should switch off. It should switch off motor 2, right? And it should switch on. Normally open means it is switching on motor 3. Motor 3 address is percentage QX 1.2, right? Next, again you go to the network, right click, box with EN. So what is this block? Means should I take GE or EQ? EQ, that is the end is 15 seconds, right? T hash 15 seconds. You can take GE also just to maintain the similarity. It will work for both. GE means what? Greater than equal. If it is equal to 15 seconds also it will work. greater than also it will work, but actually the correct one is equal, because total time we are given t1 is 15 seconds. Above that it cannot go, right? End of the process 15 seconds. So t1 dot et, then here m3. I'm not typing any address here. There is internal variable m3. So what is our requirement when m3 is on? When m3 is on, m motor 3 should be off first. Off means normally close. Okay. Next, it should reset the timer so that it can initiate one more cycle. So here line m3. So once you reset the timer, it will start one more cycle. I'm not disturbing hold variable. If you disturb a hold variable, again you have to operate start button, which I don't want, because I want to have more cycles. Okay, so when you want to stop the cycles, then you press stop button. Okay, so till the time it keep on running. Run. You should focus here m1, m2, m3. So start button operated once, then m1 is on, m2 is on, m3, so the cycles are repeated. Okay. Next, if I press stop, everything is stopped. Okay, so this is how you can generate solution. This is another way of developing solution for the same problem. And you want me to do this visualization also? You can link only motor 1, motor 2, motor 3. You can link it. And start button, stop button, you can link it. So I will do that also, just for whoever interested. What is the first step? I'll copy all the address you maintained in the program, and just copy it and then paste it in the, go to resources, global variables. In the global variables, just press enter here, then paste it. Okay, this is the very first step. Close the global variable. Now I have to resize the screen here, because I'm going to place the visualization here. Go to visualization, right click, add object, then here 3Motors, sequence, motor sequence, okay. So here, go to visualization screen, double click on it, so you'll get various features here. Go to ellipse, take okay, and next I want 3 number, and go to button here. There are 2 buttons. And this one, go to colors. Initially, maybe it is in take it gray or something, then green, then go to variables. There you have to change color. When it should change color? When motor 1 variable is on. Okay, so this one, again colors, take same thing so that it looks like same thing. green. Okay, then variables, change color when motor 2, and this one but the text we forgot actually. This is motor 3 and font size actually around 16, you can take it. Okay, this one, go to text, motor 1, font size is 16. In my case, accordingly you can take it. This is motor 2. Next, this one is text. This is start and font size 16. Let us see. And input, it's a tab variable, means it's a push button of what? Start. Okay, and text, it is stop. Input tab variable, that is stop. Font size, now go to simulation, run. Motor 3 is not working. Maybe it's not linked. Variables, yes, change color, motor 3. Run. So keeps on repeating. By operating stop, it is going to stop. Okay. This is how we can develop solution. Is there any other way? Can you do it using off delay timer? So that we'll have a discussion. Okay. So this is all. This program I will share it. Okay, program also I'll share it, and then recording also. Okay. Then